we're going to hear David Boyne with his talk, Beyond Producers and Consumers, Avoiding Common Issues with Event-Driven Architectures. Please welcome the speaker.
Thank you very much. Can you hear me okay? Everyone hear me okay at the back? Awesome. I'm going to be speaking about Beyond Producers and Consumers and Avoiding Common Issues with Event Architectures. Before I get started, I'll introduce myself. My name is Dave Boyne. I'm a developer advocate. I work at AWS. Been at AWS for about 18 months, and before that, worked at enterprises, startups, even open source full times around event-driven architecture, ecosystem, and standardizations and things like that, which was super cool. I've done that for about 15 years, and now I kind of found a passion and love for event architectures. I worked in a startup before joining AWS, using some of the services on there, but really focusing on EDA and also domain design and how they kind of complement each other, and I found a love for it. We actually had this agility that I'd never actually seen before within any engineering team I've ever worked in. We had engineers aligned with the domain, and this domain was aligned with our code, and we were flying, right? And the interesting thing is why do we want to build with event architectures? When you Google or you look at event architectures, what are the benefits you see? And you see these kind of terms come up. We have a loosely coupled system. We have producers and consumers. We're using messages or events or streams to kind of decouple these things. And in the middle, obviously, we have scalability, and then we also have extensibility, being able to extend our event-driven architectures. So think about your organization, think about change that happens all the time. So we have an architecture that we want to enable change. So what kind of patterns and what can we do with that? And EDA allows us to do that. And as you actually dive deeper into event architectures, you actually kind of seen this question kind of comes up. What are event-driven architectures? And on the surface, we talk about 3 or 4 main different things, really, which is we have the producers over here, and then we have the consumers, okay? And we use some kind of broker, some kind of queuing system, whatever it might be, pub-sub pattern in the middle, and we call this a channel. Now, I like the terminology we just saw in the keynote. I can't remember what it was called, some space-time continuum thing. That was pretty cool. But this is the kind of general gist that you get if you look at event-driven architectures. Now, there's a problem with this. And the problem is this, that what happens when you start to dive deep and build event-driven solutions, depending on what broker and technology you're using, but at times you'll have producers, the whole idea is that producers and consumers, especially consumers, come and go, right? So we're raising events and consumers, we don't necessarily know who's consuming what event. We'll come to that later. But things happen over time. Our organizational structures change. People come and go, and our architecture changes. And before long, you end up actually in something like this. And this is actually super simple to do with event-driven solutions. You end up in this weird big ball of mud where we have like unclear boundaries. We have like unclear event intent. What's inside the event? What about the standards of our event? What about documentation, discovery of our event? Has anyone worked in big pool of mud systems before? It's fun, right? Yeah. How long did you last? Because this is what tends to kind of happen sometimes, right? And it depends on where you are. It depends on how lucky you are. You might actually be brought in to do the rewrite. Well, hey, great. Or you might actually see this big ball and try and kind of move it into this rewrite system. Now, the alternative is we kind of take this big ball of mud and we try and distill it and we do something there. But it becomes really difficult to do that. And the question really is this the fault of event-driven architectures? We have producers and consumers. We have this architecture that's constantly evolving. And I think the answer there really is no, not really. And what we have to do is actually understand that event-driven architectures actually goes beyond producers and consumers. When you actually lift up the lid here, there's actually much more to it to understand. And then equally on the right here, how domain-driven design can actually complement our event-driven solutions. And that's what we're going to be talking about in this talk, is talking about some of these patterns. And what I kind of distilled it into, really diving into this kind of into this community over the last 5 years in like open source stuff and things like that, is, and talking to many people doing event architectures, is that an event-driven architecture is kind of this journey that we go on. We don't just wake up one day and say we're a producer and consumer and now we're event-driven. We have to actually identify and discover our domains and discover these events and actually start doing this stuff. So what does that look like if we visualize this journey? Well, at the top of the peaks, we have the benefits. We have this loosely coupled systems. We have decoupled architectures and this business agility, the things that we were promised. So we decide to take this architectural pattern and implement it within our organizations. Now, down in the bottom, the pitfalls. Implementation versus behavior. What happens if we implement first rather than understand the behavior first, and what the consequences? Async and sync behaviors in our organization. Lack of standards and governance, unclear boundaries and leaking information inside your events. This all happens over and over again. And that's what we're going to be talking about in this talk. Looking beyond producers and consumers, I've distilled it into three main areas. The first area is actually the benefits of event architectures, looking at actually what happens if we decide to implement first versus understanding the domain and the behavior first, and why that's a natural thing we might want to do. Implementation was to look at queues, pub sub, we'll look at these kind of things, but also enterprise integration patterns, and also patterns we can take from domain-driven design and actually put that in our architecture. And then finally, here, number 3 is actually operational maintenance, things we don't often think about. So things about discoverability, schemas, standards, documentation, all these things that we need to be able to actually scale our event architectures in our organization. At the end, I've got a summary, so we'll kind of summarize what we spoke about. And then finally, at the end, I have tons of resources so you can dive deep in your own time. So first things first is the benefits and the initial design. And a drink of water. So, why do we care about events anyway? And I think there's a good analogy here that I like to tell. As events tell the story, and the state tells us, well, the state right now. An example is, modern applications tend to use both. So, for example, if you were to query me right now, which sounds weird, do not do that. But if you were, I am on this stage giving this talk to lovely people in this conference. Okay, so your application probably needs this. Now, when you go back to talk to your domain experts or talk to people in your organizations, everyone's interested in events. How did Dave get here? What did he have for breakfast? Can we cross-sell him something? What about all this kind of stuff? So it all comes down to these events and also this state. And as I said, modern applications actually have the both. So when you start an event-driven solution, where do we actually begin? And I think I've distilled this into 2 main areas. One, we can take a shortcut across the mountain with implementation first, or we can actually do understanding behavior first. And I want to focus first on this implementation. Now, when you start building consumers and producers, something interesting happens. We have this value. We have this, actually, you can see here, it's like an initial bump in value because we have our first producers and consumers. We're adding consumers and adding producers over time. Now, as you can see here, the value tends to plateau over time as we do this. Now, why is that? Because then we map the complexity on top of event-driven solutions. So as you can see here, what tends to happen is we have our first producers and consumers. This is great. We have that initial value. We see some agility within our teams. But then we're leaking, it gets complex because we're leaking information. We're leaking domain information. We lack in standards and all this stuff. And then right at the top, if we're not careful, we definitely have this unclear domains which could lead to a big ball of mud. And to show you an example of this growth and what tends to happen is this. This is an example I'll be referring to, a simple example in this talk, but you can see here with the order service, invoice, fulfillment, and forecasting. And then we just have a broker in the middle. This could be any technology of your choice. First thing we decide to do is we create an order-created event. We are the order system. We want to create an event on this thing. So I like to call these YOLO events because we're tasked to do something. Does anyone know what YOLO means? Yeah, you only live once. Yeah, so we kind of just raise an event. Okay, so we want to do this stuff, which is cool because it works. So what tends to happen, we have an envelope inside this event. We have some kind of structure. Okay, so what we decide to do at the top is we define the event itself, the intent. The event name is very important. So in this example, order has been created. Not too bad, I guess. Down here, we might have the domain that the event belongs to. So as you can see here, we have orders. The orders domain raises this event. Again, nothing too interesting there. Down here, we have the envelope. So what goes inside this event? And as you can see, the producer has added the order ID and the user ID here. So again, this is fine. Consumers will pick this up and actually do their jobs. Everything's good. Now, what tends to happen with the evolution of this kind of YOLO event, just raise an event mentality, is that we add new events over time. So an example here would be the order cancelled event. So we are the order team. Maybe people have come and gone. Maybe this is 3 months or 6 months down the line. So we add another event. So the first thing we do is we add the reason. Why was the order cancelled? Well, it was no longer needed. Okay, so as a consumer of the event, is that information any good? Maybe, maybe not. The type. So why was the order cancelled? There's this type of TW. Does anyone know what TW means when you cancel an order? No one in the room, right? So this is leaking implementation details of this order domain into the consumers. So this is useless for consumers. Finally, down here with the user object, well, we just had the user ID. So now why is it an object? Well, we might be able to do things here. That's fine. We got the ID in there, that's fine, but now we're also leaking PII information. Can your consumers have this information or not? Right? These are things we need to consider. And then what tends to happen is more and more events come along, right? So that maybe it's a minor problem, maybe it's not. So we add more events to the order system it continues to do this. And then our event architectures continue to grow, right? We have more domains, more systems, more teams in our organization raising events. And then we have all of this stuff happening here. And interestingly, what might happen down here is we also use, we'll come back to this, also use commands as events. So as you can see down here, we're sending an invoice email. We're using our EDA platform to do this. And there's some nuances and things to think about there. One thing that often might happen is this, which is this unclear domain language. So I worked at the startup I worked in, so we were doing life insurance. And so life insurance, a customer has a policy. Okay, so the development team, we're building this EDA solution, and then we have a policy. So to us, a policy is X. Okay, a policy means that a customer has a particular thing. The insurer, when we're talking to the insurer, the domain experts over the fence, they're talking about a policy in a completely different manner. Talking about a policy that belongs to them, and a customer so happens to be part of that. Okay, it's kind of minor details, but it's all the details when it comes down to when we're modeling our domains and our events in our architecture. And then finally, the underwriter comes along, the person actually paying the stuff actually comes along and says, no, policy is something completely different. So you end up in this weird situation that EDA can kind of bring you to, which you have these unclear domains and languages being used. And there's a good quote here from Alberto. I know he's around in the conference somewhere. But here is like developers' misunderstanding, right, of the domain knowledge that gets released into the production. Okay, and that's very interesting when we talk about understanding. We go back to this model, and rather than taking the shortcut, we actually decide to understand the behavior. And when we're talking about domain-driven design, talking about practices, here we're talking about actually understanding the behavior of the system, right? The best engineers I've ever worked in the past are the engineers, as I said earlier, that the people understand the domain and the problem, and we can map this into code, right? And the collaboration with domain experts. So I've worked with like CEOs and CTOs. Again, it's a small business, but domain experts or product owners that we can actually identify the boundaries in the events and actually distill this into the code. Again, we want to identify events and have this ubiquitous language. So great thing here, obviously probably not new to most here, is when we're talking about EDA, is actually using event storming or event modeling to actually help us identify these boundaries, identify the aggregates, identify the commands, the systems, the events themselves. Because this allows us to kind of collaborate with our domain experts and actually get this language into something that makes sense. So here's an example that I did last year. This is like a car park system, just to show you a quick example of what this could look like. At the top, we have the ticket machine. Right, the ticket machine is the actor here. And then we have a command to create the event. So we're telling the system to create an event. The command can be rejected at this point, but if it's not, we create the ticket. okay, now scale this out into your organization, what we're doing here really is just trying to find the boundaries and trying to find the events. So has anyone here actually done event storming in their organization? Cool, about half the room. So that's great. So what happens when we have our events and our domains, and we're kind of mapping this architecture and getting a better understanding of this, what do we tend to do? we kind of want to jump into implementation. Okay, and when we implement with event architectures, there are certain patterns that we have to understand and certain aspects of domain design that we can bring in to actually help us do this. So first thing we need to get our head around, really, when we're thinking about systems like this, is like synchronous versus asynchronous behaviors. So your architecture will probably have both of these. So on the synchronous side of things over here, we'll raise, it could be a command like place an order, for example. So a system talks to service A, service A might talk to service B, and then we're kind of waiting for that response and that request to come back. So it's like synchronous request and that response. Over here on the right, we have the asynchronous, excuse me. We have service A, and we get that acknowledgement back, and then stuff happens in the background, right? And it's interesting when you start modeling day-to-day life with synchronous and asynchronous kind of requests and responses. Majority, I think, of our life probably sits over asynchronous events. Placing orders online, for example, or doing things day-to-day. We're very much kind of surrounded by asynchronous activities. And then when you map that to the EDA space, you kind of see this terminology. Now, it's not like kind of tightly coupled together, but there's this kind of relation between these. An example here on the left, we have commands, and then we also have events. So commands here represents the intent. So an idea here, if you're on Amazon.com and you want to place an order. So we place the order. Now, the interesting thing here is that the order can be rejected. Okay, the intent can be rejected. We're trying to do something. And this might be a synchronous request that goes back to the service and returns that response. Now, downstream, once we have created the order or we've processed this, we can raise an event. We can say that the order has been created. This is a fact. This is a mutable thing. The intent is there. And also consumers, in this example, consumers can ignore that. So there's two differences here. And again, when you start diving deeper, you actually understand that EDA is more than just producers and consumers. Talking about point-to-point messaging, talking about unbounded data with event streaming, publish-subscribe patterns, integration patterns. There are tons of enterprise integration patterns. We're going to dive into some. And then also like context mapping, domain-driven design context mapping. What does that look like when we're consuming events? And also understanding private versus public information in our boundaries when we're using events or messages to communicate between systems. So we're going to dive into all of that now. So here is an integration, a simple integration between two services with the order and the fulfillment. Now what we can do is just call this thing directly. Okay, we can say, okay, here's the order service, A, B, and C. Thank you very much. Now, what we might want to think about here is, does the order service know too much? Should the order service know about this fulfillment service? And then also about protecting downstream consumers, right? So the fulfillment service could be a third-party service or some other team owning this. So if it was Black Friday, for example, we get loads of orders in here. What happens to the fulfillment service? Can it kind of keep up with this process, this rate? And also, what happens if we get the failures? So this whole synchronous kind of commands going through, failure, and we get that back. So now we've got a bad user experience. So of course, what do we do here? What can we do here? We can implement something like a queue. Okay, so what we do is we take the information, we put it onto a queue, and the queue is processed sometime in the future. The fulfillment service actually pulls information off of the queue to process this. What we've done here is actually decouple the order and the fulfillment service. And then we also isolated failures. So we can set up something like a dead letter queue as an example to actually process these rogue messages off the queue here. And that's what we're talking about here is actually, when you talk about event-driven solutions, your event-driven architectures will probably have some kind of point-to-point messaging across them. As you can see here, we have like many different kind of receivers pulling information off the queue. Now, a good analogy to think about this, we kind of mentioned it in the keynote actually, which is shopping. Right, so has anyone got children here? A few people? Only a few people, wow, look at that. So like if you go Christmas shopping, so I have children, I go Christmas shopping, right? It's a nightmare, do not do it. So I go Christmas shopping with my children. They pick out some stuff, I go back and then I kind of put it in the basket or whatever. The queues are massive, right? The queue's just going out the door, I leave it too late. Now, if you're lucky, you have some cashiers that can kind of process this queue, but if you're unlucky like me most of the time, you have 1 or 2 people processing this. And that's the same kind of thing when we're talking about queues, is we can actually expand the receivers and actually deal with the messages that come off faster. So in that example, we'd have more cashiers kind of open up and the queue would be processed. And that's exactly what we're talking about. So again, just bring that down. There's a sprinkle of AWS services in this talk. Not too much, but this is Amazon SQS. This is the first service actually we released. Is anyone using SQS? Curious? Okay, so about half the room there. Cool. So actually, it almost scales infinitely, which is interesting to think about. Easy to kind of use API and supports like dead letter queues. So if you're interested in queuing systems on AWS, SQS is the one to have a look at. So next kind of thing that you might get along is some kind of requirement to notify downstream consumers that something has happened. Okay, so what we can do here, again, if we really wanted to, we could just call these things directly and notify them. That will work, but of course, we're back to square one. Order service knows too much, duplication of effort, and how do we handle failures across the system? So what happens is we introduce something like an event broker, like publish subscribe kind of pattern, right? We spoke about this earlier, whereas we actually notify the systems downstream that something has happened. Now the downstream consumers don't really care; they come and go, and they subscribe as and when they want. Now again, what we're talking about here, as I just mentioned, is pub sub patterns. Is anyone doing this? Kind of pub sub patterns, cool. Again, about half the room. So it's kind of this push model. We spoke about pull and push models in the keynote, but this is kind of a push model to downstream consumers, right? So we have here, you might have some rules on your broker if it supports that. And you can say, okay, I'm interested in the blue ones, I'm interested in the purple ones. And we have these events flying through the system. And the receivers actually get their own copy of that message, and they can kind of process this. So again, if you're, again, the sprinkle of AWS here, but if you're using AWS, we have something like Event Bridge, which allows you a fully managed event bus service. Is anyone using Event Bridge? Okay, about, 5, 6 people. So we have like 28 different AWS targets, but the bit that interests me the most with event-driven architectures in general is the integration between systems. And we spoke about flow in the keynote, the interesting integration between events in our systems. And there's a good book called Flow Architectures that I recommend if you've read that or not. But what it talks about is actually the future of event-driven systems and the ability to kind of listen in on streams and get real-time information off that. And I think as we talk about events and API destinations, this is just an example of integration with APIs. I think we're kind of going into that future. Next thing, when you kind of build EDA solutions is this, which is like event streaming, which is talking about unbounded data. So this is data that we don't really know that ends. Okay, so an example would be click streams on your website, right? Just collecting all this information and thinking about that. So how do we process that and what do we do? So obviously we have like Kafka or Rabbit as an example there that we can use to do this. Another common pattern that you'll see people use in event-driven solutions is obviously like things like change data capture, which allows us to listen to changes in the database, allows us to listen to inserts or updates or deletes, as an example, inside the log, and be able to react to these downstream, which is an interesting pattern. Now, the thing is, you've got to be careful about this one, is if you're reacting to the information, what about the schema? What about this information that you're getting? You're going to get the raw information out of the database, so you might want to kind of map that into something that makes sense. And talking about mapping and talking about integration patterns, so we spoke about pub, sub, and queues, but what else is there? And this is some of the integration patterns that you might see when you decide to dive deep. This is an example that happened to me before. I'm not sure if it's happened to any folks here. But I walked in one day inside this company, and we thought the system had gone viral. We thought we had all these users. Our service was going through the roof. One of the services, an example here would be the order service. And what's interesting is that wasn't the fact at all, is that we had more consumers of the events. And the information inside the events were very sparse. They just had the ID in it. All right, so the consumer says, thank you very much. Thanks for the ID. Now I'm going to go back to the producer or some kind of API to get this information. So just weirdly, you kind of put this back pressure on top of the order service. Now, when you map this to like integration patterns with messaging and event architectures, you can kind of solve this by using some of these. So if you come across some of these weird and wonderful EDA things, there's actually patterns designed to help you. One here is the content enricher pattern. Okay, so what we do here is we inject some middleware. So we can say, okay, well, you as a producer, you can keep your contract simple, which is great because simple contracts mean we can, there's less likely of breaking contracts downstream that they're easier to maintain. But downstream, if your consumers want more information, we can put this logic in something like this, which is an enricher. Equally, you might often come across this, which is when you're trying to process messages that are just too big. Has anyone had this problem before? Yeah, a few hands. A few nods. So your broker will have limits, okay? So how do we process messages or events that just go beyond these limits? Again, when we map these problems into certain patterns, the patterns can help us. So an example here would be one we call one that's called claim check pattern. Okay, so where we get a message that comes in here, and the producer, before he raises the message, actually we store, excuse me, store the information inside a database with a key. Okay, and then what we can do down here as the consumer is we can go back to the database or the storage, wherever that might be, with the key and receive it. Now, there are trade-offs here to consider, right? The consumer now needs to know and have permissions, whatever it is, to talk to this thing in the middle. But this is kind of one way around these particular problems that you might not be aware of. There's an interesting pattern here, which is contracts and schemas. When you're talking about event-driven architectures, it's very often overlooked about versioning contracts and schemas and languages. One thing is very interesting, again, this coming back to domain-driven design, is context mappings and how we can use these to help us build our event-driven solutions. So if you're a consumer and you consume an event, the majority of the time you'll be a conformist. Okay, you'll take the event as it is and you'll do stuff with that payload and that information. Now, the interesting thing here, yeah, that's great, fine, but that model, that event, can kind of easily be, I guess, splattered, I'm not sure of the word, across your domain and your code. So how can we kind of, where in domain-driven design, what can help us do that? So the one solution there is we create an anti-corruption layer, right, between the models. So we create the event, and we use an anti-corruption layer to actually map it into a language that we understand as a consumer. So again, going back to the example, the order service creates an order. The fulfillment service doesn't want to particularly maybe not deal with that order language, so we map that into something we understand. Again, if you continue to dive deeper, there are other scenarios like open host service. This is where we actually we describe a common and public language that we're going to use between our messages and our events. Right? We transform this before we publish. So the producer is now doing this, and the consumer kind of expects that kind of thing. And there are about 3 or 4, excuse me, 3 or 4 different ones that you can kind of dive deep in if you want to. But it's just to understand that you actually, without doing it or thinking about it, you will be you will have the conformist pattern in there. And that can actually be an interesting side effect to your architecture. Another interesting thing here is this, which is private and public information. Right, again, often overlooked. When we're building our event architectures, when we're talking about our context, our bounded context, our systems, what is private and what is public? So for example, you could have message brokers or queues inside of your boundary, and you can use this information. Now, the interesting thing here is that your messages and your schemas and your contracts are a lot different to the ones that you publish externally. When I mean externally, I don't mean like it could be external parties elsewhere, but external kind of domains within your organization. So an example here, you've got A, and we're raising event, and the consumer here will kind of just consume that. But the interesting thing here is it can kind of have implementation details, right? Is there a risk of having that type TW in this? Question, maybe not, because this domain might understand that language. Now, equally over here, as we're raising events on a public interface, it's very, I guess, risky in a way to actually expose some of this implementation details, because you don't want to have consumers kind of bound to these details here. And what I'm kind of getting at with this is that event-driven architectures really is, I mean, I just covered a few of them here, but really is just a collection of patterns. Has anyone read the Enterprise Integration Patterns book? Okay, about 10, 15. So it's a great book by one of my colleagues, Gregor Hopp. It's actually written 20 years ago, believe it or not, over 20 years ago. And the pattern language that are used in there about messaging is still relevant today. So if you come across like particular problems that you're having with your event architectures or your solutions, I can almost probably guarantee there's something in there that might be able to help. And of course, we have Learning Domain-Driven Design book here by Vlad, which is fantastic. But EDA actually, what I've kind of distilled it into is a collection of these patterns, a collection of these things, and and domain-driven design can actually help us get there. And number 3 here is actually talking about operational and maintenance. So when you're 6 months or 12 months or 2 or 3, 5 years down the line with your solutions, what are the problems and what can help? So the interesting thing here is when you kind of map out event architectures, you see this. We have this high agility and low complexity. This is where we want to get to. This is the dream that we've been sold, I guess. But what tends to happen over time is this, which we have this high agility and the complexity starts to kind of creep in. And then down here, if you're unlucky, you start to have that low agility and again, that high complexity. And I think it all comes down to this kind of this term. Has anyone kind of seen this before? It's very common, right, within this community. We talk about producers should not know about consumers. This is the whole point. We're decoupled, and this leads to some very interesting problems. So we have again, we have the example here, and then what happens is more and more consumers come. In fact, we scale our architecture, our team topologies, we scale our organization, we have more event buses, we have more producers, more consumers, and the list goes on. The interesting question that often comes up is this, is what events do we have, right? And also, what are the payloads of the events? And also the question of who is consuming what. Has anyone kind of had these particular problems? Yeah, a few people. So it's kind of like, okay, how do we do that? How do we deal with this? And it's interesting because I guess, yeah, producers should not know about consumers. That's fine. This from a tech point of view. Yeah, producers should not know about consumers. That's how we remain decoupled. But that doesn't kind of mean that we can skip the governance stage of event architectures, right? And what do I mean by that? I mean about things like standards, discoverability, and also communication. So in standards, for example, we have payloads and like common SDKs that we can build, and also event-first thinking, treating events as first-class citizens of our architecture. And then here in the middle, we've got schema registries. Is anyone using async API? Heard of that? Cool, about 5, 6 people. And then event catalog. And then also we talk about communication. So we're going to dive into these and actually distill and kind of break these down. So here we talk about event standards. So when you raise a message, raise an event, the payload is up to us. The envelope is up to us. Now, a lot of people I'm speaking to, a lot of people in the community, what they tend to do is actually raise events with some kind of metadata in them, right? So think about the information that you want all your events to contain. So it'd be correlation ID, could be timestamps, could be all of this kind of stuff. But that's a good base to start on when you start raising your events, because you can kind of do some interesting observability and things down the line with that. So thinking about standards can really help you. Also thinking about events. Okay, so there's something called event, I spoke about last year, which is event-first thinking. It's an interesting thing when we get a requirement that comes in with kind of most of the software that we build, I guess, is we get the requirement, we design it, and then we implement it. And it's the same with events. We get an event, some kind of requirement to come in, we implement an event, and then we do something with it. It's a very linear process, but we can actually change that and spin it on its head. And there's kind of this evolutionary architecture, and our systems are in evolution. And as we discover our domains and discover these problems, we need to go back into our events and actually identify them again. And actually, we need to define them and then again implement them. Okay, so it's not this linear process. Once we have an event, it's done. The events will evolve with your domain as you kind of explore. So if you're interested in that, I've got like a 40-minute talk here where I kind of dive deep into that subject. The next thing is around schema registries and discovery, okay, and what is out there that can help you, what standards are emerging, and what tools can help you. So schema discovery. So some brokers might support this, some might not, but this is an example. You can have actually brokers that populate schemas for you. So you can take these schemas and use tools off the shelf to be able to actually do things like code bindings in your IDE. These actually help you discover and use your events, then questions about what is it the payload. As new people come and go in your organizations, you need to be able to find these events and kind of deal with them. One interesting solution out there, so this is the project I worked on full-time in the open source space for a while. Fantastic community, fantastic people, which is Async API. So it's actually a fork of Open API, and it's actually the ability to document channels. Messages, publishers, and consumers. And the fascinating thing, what happens here when we start to standardize the ways we do this stuff, is we can create tooling off the back of that. And there are hundreds of different plugins and tools that you can go on. So again, if you're interested in documenting your architectures, I really recommend checking out this community. And again, they have various different bindings for Kafka, Rabbit, and many different brokers. And finally, I'm actually a super big geek when it comes to schema discovery and documentation. So a bit of a shout out here, but I created this tool that seems to be getting a lot of attention at the moment. But what this allows you to do is actually document your events, document your schemas and your domains and your services. And actually, this is all static HTML kind of rendered with Markdown and using MDX components, if any React people are here. But what this allows you to do is actually take your domains and take your events and create plugins and be able to actually document and visualize your event architectures. Because it is a big problem. It's a 3D graph here that I kind of just randomly built because I was bored one night. But yeah, it's an interesting problem because, as I said, I kind of released this to the community, and many people are coming and looking at this. And then finally, talking about operational maintenance, and it's just coming back a bit to DDD, I guess, which is about this communication, right? Is understanding the domain models within the boundaries, understanding this public information, this connection between systems, because we use events to talk between systems. We use event messages or APIs as an example, but just to really realize that the language between these domains will probably be different, and that's something we need to embrace. So is it a public language that we're going after, or is it anti-corruption layers that we need to implement? So just considering that. Because I think if you look at discoverability, documentation, and kind of focusing on this area, we want to move away from number 3. And I've spoke to a lot of people in the community about being in number 3. And when you kind of dive deep into that, it's kind of they're missing some of these core aspects. And just push into this high agility and kind of low complexity that I think and I believe that EDA can kind of bring to your architecture. And with that, I kind of just want to summarize everything we spoke about and kind of give you loads of resources to dive deep if you want yourself. I mentioned at the start of this talk that event-driven architecture, in fact, is kind of this journey that we go on. Like most software systems that we have, I kind of visualize this journey like this, which is at the top, we have the benefits of EDA, right? Again, when we're kind of looking into event-driven architectures to kind of help us build our solutions, they are there and they can help. But equally, you have these pitfalls along the way. So again, unclear boundaries, leaking information. We kind of want to move away from these pitfalls the much we can and kind of be at the top as much as we can. We spoke about initial design, spoke about events. Why do we care about events? Events kind of tell us the story. We spoke about behavior first can actually really help us understand our domains and our events. And we can dive deeper with our domain experts and actually try and map that domain into our event architectures that can help us. And again, event storming or event modeling are very good methods to do this. We spoke about here event types, so like commands and events and async versus sync. Spoke about messaging patterns and integration patterns. Okay, understanding that we have queues and point-to-point and change data capture. There are things there that can help us, but equally, as we kind of come across these nuances, there are integration patterns that can help us with enrichment and storing and context mappings. And then really just understanding, for me anyway, that EDA is really just a collection of patterns and collection of these things. And then finally, we spoke about operational maintenance, talking about standards and discoverability, like using things like async API or ways to document your event architectures can really, again, help you kind of move away from being in that high complexity mode into something that's more usable. And then again, communication. We kind of want to reduce that complexity that EDA naturally kind of brings to our systems. And I think with some of these things, that can help. We spoke about some serverless services in this talk. Is anyone building on, I'm curious, anyone building on AWS or serverless? Cool, again, yeah, about half the room, awesome. So we talk about like SQS, which is the message bus that we have, EventBridge, being able to do publish, subscribe. And we also spoke about DynamoDB as the NoSQL database using change data capture to listen to things. One thing we released at reInvent last year was EventBridge pipes. If you're interested in point-to-point communication with things like Kafka into AWS as a prime example, pipes can kind of really help you dive deeper into that. I go to a lot of conferences. We do a lot of speaking around various different things. We have this thing. Has anyone ever seen this, Serverless Espresso? No one. I probably thought not. Oh, one person. Awesome. How was the coffee? It's good. So we built this solution using event-driven solutions on AWS. We have workshops online. Everything's open source here, and you might see us at an event, but it's all about coffee ordering. So you go up, you scan your QR code, get a coffee, and then everything's going through that system there. So if you're curious, check that out. One thing I started this year is EDA visuals. Has anyone seen this? Awesome. Right, 2 free people. Wow, let's go. So I started this earlier in the year. I kind of just, everything I'm learning, distilling it into bite-sized chunks. So if you've got 5 minutes spare, there's over like 50 different visuals here. It seems to really resonate with people. There's a lot of domain-driven design stuff there and EDA stuff. So you can download the whole thing for free. Check it out. It's all free. I enjoy making them. So if you've got any feedback on that, that'd be great. And then finally, at the end here, I have all the resources, so everything I kind of dive deep on. If you want to dive deep yourself, is all on GitHub. There's a whole stack here around initial design, everything you can find there. And with that, I just want to thank you so much for your time. I hope you found it kind of useful, and there's bits you can take back to your organization. If you've got any questions, feel free to grab me in the hallway track. I'm here today and tomorrow. So yeah, with that, I just want to thank you all so much for your time.